Before this video starts, please hit the subscribe button. It helps my videos out a lot. In this video, we will learn about system of equations in math. Let's say we had an equation where it says x minus 4y equals 36. 7x plus 4y equals 28. Pause this video and try to solve this on your own. Now, if this problem here seems very hard for you, this may be the scenario because you may have only dealt with equations with only one variable before. For example, something simple like 2x plus 5 equals 15. In this case, you would just subtract 5 from both sides and you would be left with 2x equals 10, and then you would divide 2 by both sides and you get x equals 5. Or you can probably solve something simple like 7y minus 7 equals 42. In this case, if you solve it like something similar to this right here, you would get y equals 7. Here is a more complicated problem, something like 4 times 5x plus 20 minus 8 equals, let's say, 100. At the end of the day, you may be able to solve all of these problems right here, no matter, like these two at the bottom are kind of easy. This one's a bit more complicated, but you may be able to solve all of these because at the end of the day, all of these problems only have one variable. But this equation right here has two variables. Let's get to that. Okay, so here's the thing. If you only had one equation with two variables, for example, if I just got rid of all this part right here, you would actually not be able to solve this because it's actually impossible. So if you have an equation with two variables, you need at least two equations. That's why it is called a system of equations. Now there are two methods of solving this. The elimination method and the substitution method. I will be going over both of these methods in this video, so this video might be kind of long because I'm going over both methods. There is a third method where it's graphing, but elimination and substitution are solved algebraically, while graphing is, as you can tell by the name, is solved by graphing. So today I will only be going over the problems that are solved algebraically, so I will probably explain graphing for another time. First, we will look at the elimination method. So, the way you do elimination method is if you have an equation like this, the first thing you would do is check if there are any variables that are the inverses of each other. For example, an inverse is something like negative 3 and 3, or negative 46 and 46, or 7 and negative 7. You get the point. Now we see that negative 4 and 4 are inverses of each other. These coefficients of y are inverses of each other. So in this case, what you would do is you would add both of these equations. So the way you add equations is very similar to how you add with regular numbers. You would put a plus sign here and put a giant line. So you would just add one by one. So from right to left. So on the right, we get 36 plus 28 equals 64. Then equals goes over here. Then we do negative 4y plus 4y. Now, negative 4y plus 4y equals 0 because the coefficients, they're like terms, so you would add the coefficients, and negative 4 plus 4 is 0. So you would get 0 here. At the very end, you would do x plus 7x. And when you add like terms of 7x plus x, you get 8x. So you would put an 8x right here. And then to separate these together, you would add a plus here, because this was the y variable. It says 0, but before it was the y variable. Now 8x plus 0, 0 doesn't have any value. So we can just say that, let me just erase this part. We can just say that 8x equals 64. Now this is very easy now. This is just a one variable equation. So now we can do divide by 8 on both sides. And we get x equals 8. Although we have x is equal to 8 right over here, we are not done yet because these two equations have both x and y variables. So there are two variables. So we have to solve for y as well. Now that we know what x is equal to, it's very easy to solve for y. So for example, let's plug in x into the first equation. Now we know that x is equal to 8. We can substitute 8 as the value into the equation. So you would get 8 minus 4y equals 36. And you would, this is a single variable equation, so it's kind of easy now. So you would subtract 8 from both sides, and that would give you 28. And then you get negative 4y equals 28. And you divide 28 divided by negative 4. So you divide negative 4 by both sides. And you get y equals negative 7. Now we are done. We have both variables solved, x equals 8 and y equals negative 7. Now, how do you check your answers to make sure x equals 8 and y equals negative 7 is the correct answer? We can use that by plugging in both the x and y values into the second equation. Now, since we used the first equation to solve for y, we would use the second equation to make sure, because we have not used it yet. So x equals 8, so you would just substitute the values x and y into 7x plus 4y equals 28. So you would substitute the values of 7 times 8 plus 4 times negative 7 equals 28. 7 times 8 simplifies to 56. And 4 times negative 7 simplifies to negative 28. 56 plus negative 28 is equal to 56 minus 28, which results in 28. 28 equals 28. So now we know that our problem is correct and x is equal to 8 and y is equal to negative 7. This is how you solve system of equations with the elimination method. Let's do a few more methods to get used to this method. Let's say we had 4x plus 6y equals 40. And then we also had 7x plus 2y equals 53. Now, in this case, what we did is we tried to look for inverses of each other. And remember, the inverses of each other are something like negative 2 and 2. But now you see that both x values, 4 and 7, and 6 and 2, do not have inverses of each other. So how would you solve this? Since we don't have inverses of each other, we should try to choose one variable to eliminate. I'm going to choose the y variable to eliminate, because if you multiply 2 by negative 3, you get negative 6, and which is an inverse of each other. So we're supposed to multiply the entire equation by negative 3. So this would result in, if we do that, we would get negative 3 times the entire equation. Now we multiply it using the distributive property. So we do negative 3 times 7, which is negative 21x. Remember, we have to use the x as well because it's the coefficient of a variable. Then we do negative 3 times, then we do negative 3 times 2 to get negative 6y, because 2 is the coefficient of y. And then we do negative 3 times 53 to get negative 159. Now we have two equations that are inverses of each other. Let me write it down here so it's easier to read. So the first equation is 4x plus 6y equals 40. And the second equation is negative 21x minus 6y equals negative 159. Now we can add these two equations to use the elimination by using the elimination method. So just like we did before, you would do 40 plus negative 159 on the right to get negative 119 equals. Then you would do 6 plus negative 6y, so 6y plus negative 6y. So they cancel out, which results in 0. And 4 plus negative 21, which results in negative 17x plus 0. Since 0 has no value, we could just say negative 17x equals negative 119. Now we divide negative 17 by both sides to get negative 119 divided by negative 17, which is x equals 7. Now we are not done yet, like we know before. We're trying to solve for both x and y. So we are going to try to solve for y as well by plugging in x equals 7 into one of the equations. Let's plug it into the first equation. So we would get 4 times x, which is 7. So we plug in 7 for x, plus 6y equals 40. So 4 times 7 simplifies to 28 plus 6y equals 40. And then you subtract 28 from both sides to get 6y equals 12. Then we divide 6 by both sides to get y equals 2. Now we are done. X equals 7 and y equals 2. Let's make sure our answer to these equations are right by plugging it back into the problem. Now since we used the first equation to solve for y, let's plug it into the second equation. So negative 21x minus 6y equals negative 159. I just copied this equation down here so it's easier to read. So we can plug in both the values of x equals 7 and y equals 2 into this equation. So we would plug in negative 21 times 7, which is by substituting in 7 for x, and we substitute 2 for y, 6 times 2 to get negative 159. So let's simplify this. Negative 21 times 7 is equal to negative 147 minus 6 times 2 equals 12. Negative 147 minus 12 is equal to negative 159. So negative 159 is equal to negative 159. Now, since that is a true statement, we know that these values for x and y is correct, and we solved the equation correctly. Let's do one last problem for elimination, and we can move on to the substitution method. Let's say we had negative 2x plus 10y equals 2. And another problem saying 5x minus 25y equals 3. Now, we're trying to look for inverses of each other, and since we don't have any inverses of each other, we're supposed to multiply the one or both equations to get variables that are inverses of each other. Now, if you look at both equations, there are no there are no whole number integers where you can, let's say you multiply negative 2 by some number, you can't get 5. You can't multiply 10 by a whole number to get negative 25 either. So we have to multiply both equations. So if we multiply the top equation by 5 and the bottom equation by 2, we will actually get inverses. Because if we do multiply by 5 to the first equation, using the distributive property, we can say that 5 times negative 2 is equal to negative 10 x, because it's a coefficient of x. Then 5 times 10 is equal to 50 y, because it's a coefficient of y. And 5 times 2 at last is equal to 10. And then we multiply the second equation by 2 to get 2 times 5 using the distributive property to get 10x 2 times negative 25y to get negative 50y, and 2 times 3 to get 6. Now we have inverses of each other, negative 10x and 10. Before we continue, you may have noticed that we can actually multiply the first equation by 2.5 or 5 over 2 to get negative 5x, which is an inverse of 5x, right? But here's the thing. When we multiply it by 2.5 or 5 over 2, we get fractions in the rest of the equation. And if you ask me, it is kind of annoying to deal with fractions. So that's why I use two whole numbers so that we don't have to deal with fractions. But if you think fractions are easier for you, go ahead, you can do that as well. Now we just add both of these equations using because of the elimination method. So we would, because we're trying to eliminate a variable, so we would do 10 plus 6, which is 16, and you get 50 plus negative 50y plus negative 50y, which is, 50y plus negative 50y equals 0. So these cancel out and you get 0. And then it's the same case for x as well. So negative 10 plus 10, which is negative 10x plus 10x, and these cancel out and you get 0 plus 0. 0 plus 0 is obviously 0. And you get 0 equals 16, which is a strange result because 0 is obviously not equal to 16. And you just realized that your goal was to eliminate only one variable like x or y, but instead you eliminated both. Don't worry, you didn't do anything wrong. This basically means that this equation has no solution. No solution. So there can be equations in system of equations with no solutions. So this problem has no solution, so x and y is undefined. Let's move on to the substitution method. Now let's think about it. Now let's get introduced to a new method, which is the substitution method. So let's say we had x plus 2y equals, 100. And then we had x, then we had y equals 2x. Now these are still two equations, but now we know that since we know that y is actually equal to 2x, we can substitute 2x into y. Now you can understand why it's called the substitution method, because we are substituting x into the y variable because we know y is equal to 2x. So we would do x plus 2 times y, which is actually 2x. So you would substitute 2x in, and then you get equals to 100. So let's simplify this part of the equation to x plus 2 times 2x, which is 4x. Sorry, this is supposed to be 100, is equal to 100. Now we can now we know that x plus 4x are like terms, so x plus 4x is equal to 5x equals 100. And then we divide 5 by both sides to get x is equal to 20. We're not done yet because we're trying to solve for y as well. Now it's actually easier to solve for the second variable in the substitution method because you just substitute in a variable and it tells you the answer. So we know that x is equal to 20. So let's substitute x is equal to 20 into the second equation because we are just trying to figure out what y is. So y is equal to 2 times 20 is, because we just substituted 20 for x, so 2 times 20 is equal to y is equal to 40. So we get x is equal to 20 and y is equal to 40. Let's make sure these answers are right by substituting these both values into the first equation, since we use the second equation to solve for y. So we know that x is equal to 20, so I'll just bring this equation down to make it easier to see. And I'll bring this what y is equal to down. So we know that x is equal to 20 and y is equal to 40. So we substitute both values. So x is 20 plus y is equal to 40. So 2 times 40 is equals 100. Let's see if that's true. 2 times 40 is 80. So 20 plus 80 equals 100. And 20 plus 80 is 100. So 100 equals 100. Now, since this is a true statement, we know that x is equal to 20 and y is equal to 40 is the correct solution. That's how we use the substitution method. Let's do a few more problems with the substitution method. Let's say we had x minus 7y equals negative 11 and 5x plus 2y equals negative 18. So let's use the substitution method to solve this. Let's substitute for x. Now, we don't have any equation. Both of the equation are kind of similar to how we dealt with the elimination problems. So how do we find what y is equal to or x is equal to? Let's use the first equation, for example. So x minus 7y equals negative 11, right? Now we can find what x is equal to by adding 7y to both sides, right? Because then this cancels out, which results in x is equal to 7y minus 11. Now we know what x is equal to. We can substitute the value of x into each x variable. Now that we know what x is equal to, let's substitute x is equal to 7y minus 11 into the second equation. So the second equation is 5x plus 2y equals negative 18. Now we try to substitute x, so it's 5 times 7y minus 11 plus 2y is equal to negative 18. So we have to use the distributive property to simplify. So 5 times 7 is equal to 35y, and 5 times negative 11 is equal to negative 55. So 35y minus negative 55 plus 25, bring this down, is equal to negative 18. So 35y plus 2y, we're just adding like terms here, is 37y minus 55 is equal to negative 18. Now we add 55 to both sides to get 37y is equal to 37. Wow, what a cool number. So we divide 37 by both sides, and as you may have guessed, y is equal to 1. We're not done yet because we're also trying to solve for x. We know that y is equal to 1. So in the first equation, you would get x minus 7 times 1, because y is equal to 1, equals to negative 11. So you would simplify this by multiplying 7 times 1, which is simply 7. And x minus 7 is equal to negative 11. So x minus 7 is negative 11, so you would add 7 to both sides. That's a 7. Sorry. So to get negative 11 plus 7 is equal to x is equal to negative 4. Now we're done. X is equal to negative 4 and y is equal to 1. Let's substitute both values, x is equal to negative 4 and y is equal to 1, into the system. Let's use the second equation because we used the first equation to solve for x. Okay, so in the second equation, we can see that we can substitute both values. So 5 times negative 4 plus 2 times 1. I just substituted x and y is equal to negative 18. So 5 times negative 4 simplifies to negative 20 plus 2 times 1, which is just 2, is equal to negative 18. Negative 20 plus 2 is negative 18. Negative 18 equals negative 18. This is a true statement, so we know that these values for x and y are correct. So these are the ways to solve system of equations with any equations with two variables using the substitution and elimination method. So since we learned about both of these methods and how to solve system of equations algebraically, Which method should you use? Elimination or substitution? Here's the thing. It really doesn't matter. Whatever you find easier. Sometimes I find the elimination method easier. Sometimes I find the substitution method easier. So whatever you found easier when you were learning today, use that method to solve system of equations. But let's say you like the substitution method. Don't use the substitution method all the time. It also mainly depends on the problem. If the problem is easier to solve using the elimination method, then use the elimination method. And if it's easier to substitute in a value of a variable to eliminate a variable, then use the substitution method. At the end of the day, no matter what method you use, you should still get the right answer.